Welcome to EDU World Space.
Let x be a 0.9, basically 0 followed by infinitely many nines. Use shorthand notation to represent that. For part A, do you think that x is less than 1 or x equals 1? So I know the answer already, so
Here's a clean and
but let's
professionally
just
formatted
make a guess
presentation
here.
of the
Make your
calculation
own
shown in the
guess and then
image.
record it. And then we'll come back to that guess.
Application of the work energy theorem.
So
wet.
here
From the work
we'll
energy
end up
theorem,
seeing that
the
it
force
is
F is
exactly
given
1,
by
which
F
is
equals frac
quite
X
surprising to most
KE,
people
where
because
KE
it does
equals
have a
kinetic
0 as
energy,
the
S
on
equals
the left of
stochastic.
the decimal,
I'm given
but
for
we'll
object
see this
A,
in part B.
FA
Let's
equals
go ahead
frac
and prove it using
100,000
part B. So
0.10.
sum
For
the
object B,
geometric
FB
series
equals
to
frac
find the value of
225,
x.
1500
So here all they're
equals
saying is
0.15
let's
text
first
ratio.
write x
And force ratio frac
as
FA,
the sum,
FB equal frac 0.10, 0.15 equal frac 2
and
null
so
result.
on.
I'm a box frac FA, FB.
Now
Would you
we
like
can
a
write this as
PDF
9
version
over
of
10,
this explanation?
9 over 100, 9 over 1,000, and so on. And now it's starting to appear that we have a geometric series. And we know the sum of the geometric series, sum equals the first term over 1 minus the common ratio r. This is for a geometric sum. So the first term, we see that's 9 over 10. And then we divide by 1 minus. And what is our value of r? What are we multiplying by each time? It's 1 over 10. So we have 9 over 10 divided by 9 over 10, and that's exactly 1. So that verifies that the guess in part A was correct. And then C, how many decimal representations does the number 1 have? Well, we have one decimal representation in this form. Let's just write it that way. However, we just saw in the part B here that we can also write it as, or if you want, just 1.0 with a bar. So these are two distinct decimal representations of the same real number. So 2, that'll be our answer for part C. And now let's generalize this to other real numbers. Let's go to part D. Part D is asking, when do two real numbers have the same decimal representation? So let's answer this. The only real numbers with two decimal representations have their decimal representations agree up to some point. Then one of them continues with, so this is after they agree up to some point, and then after that point, one of them look like A, and then followed by infinitely many nines, and the other one is the other one. So this is the part in which they agree, these blank spots right here. That's the part in which they agree up to some point. And then that number A is the first time that they split up, and the other one, instead of A, it goes into some other number B, followed by infinitely many zeros. And here, B is just A plus 1. So for example, we already saw an example in part C, 5, and here's another one. So these numbers agree up to 6, and then after that, we have A here, which is 7, followed by infinitely many 9s. And then here we have B, which is 7 plus 1, and then followed by infinitely many zeros. And in part A, we saw that 1.0 equals 0.9. So here, these numbers agree up to some point, but technically, they don't have to agree at all. I mean, but it is possible, as we saw in this example here, underlined in blue, green, it is possible for them to match up for a few decimals. Then you have a point in which this switches. But if they don't agree up to a certain point, that's also fine as well. As long as here's our A, then you have A plus 1, and then the A's followed by infinitely many 9s, the B's followed by infinitely many zeros. So this is the only time in which a number will have two representations, and that's the final answer.